66 million years ago, a 10-kilometer sphere of rock and iron hurtled toward Earth at 20 kilometers per second. But in this timeline, the gravitational pull of Jupiter tugs it just a fraction of a degree. Instead of hitting the shallow seas of the Yucatan Peninsula, it strikes deep water harmlessly. Tsunamis devastate the coastlines, but the ocean traps the sulfur. No global dust cloud forms. The sun continues to shine, the plants continue to grow, and the dinosaurs' 165 million year reign continues without a pause. We are often taught a comfortable narrative that dinosaurs were lumbering, cold-blooded evolutionary dead ends, simply waiting around for small, intelligent mammals to inevitably replace them. Look closely at what this geologist is pointing to. That is a thin layer of iridium-rich clay marking the KPG boundary. That is the physical reality of our timeline. Without the catastrophic intervention of that specific asteroid, the transition to the age of mammals is never written in stone. The impact was a random cosmic accident. It interrupted a biologically superior dynasty, operating at the absolute peak of its diversity. Look at this side-by-side comparison of respiratory systems. Mammals breathe inefficiently. We pull air in, mix fresh oxygen with stale carbon dioxide, and push it back out. Dinosaurs had unidirectional lungs. Air flowed in one direction only, passing continuously over gas exchange surfaces and extracting massive amounts of oxygen per breath. When you combine that respiratory engine with hollow, air-pocketed bones, the structural limits on body size vanish. Dinosaurs could grow to 50 tons without collapsing. Mammals, constrained by heavy, solid bones and inefficient lungs, hit a biological ceiling. Early mammals were caught in an ecological trap. The giant dinosaurs blocked them from above, while other highly specialized, and now extinct, mammal lineages dominated the small to medium niches around them. Mammals were competing in an arena where the physiological rules favored a completely different body plan. Barring an apocalyptic event to clear the massive ecological real estate above them, they were permanently locked out of the megafauna niches. 23 million years ago, the planet's thermostat dropped. Rainfall decreased across continental interiors, causing the dense global forests to recede. Taking their place were vast open plains covered in a tough, abrasive new plant, grass. Grass tissues are laced with silica, which acts like microscopic sandpaper. To eat it without grinding their teeth down to the nerve, herbivorous dinosaurs like ceratopsians would adapt. Their dental batteries would evolve to grow continuously to replace worn teeth, while their beaks widened into flat grazing tools. You can see the scale of the necessary defense strategy by looking at modern bison. Out on the open plains, there is nowhere to hide. Survival requires vigilance. Grazing dinosaurs would mass together in herds of thousands, utilizing hundreds of pairs of eyes to spot threats on the horizon. This exposed environment created a critical problem for a heavy ambush predator like Tyrannosaurus rex. Without forest cover, prey could spot a 6-ton giant from kilometers away. To catch highly alert grazers, the Tyrannosaur lineage would have to shed weight, lengthen its legs, and evolve into a leaner endurance runner. Notice how these African wild dogs operate. A lone, slimmed-down T-Rex still couldn't safely bring down a large herd animal. They would have to coordinate in packs, flanking targets, cutting off escape routes, and slowly exhausting their prey over miles of open terrain. The death of the forests did not kill the dinosaurs. The abrasive plains simply forced them to adopt the exact same survival strategies we see in modern savanna animals today. 2.5 million years ago, the ultimate stress test arrived. Global temperatures plummeted, and advancing sheets of ice aggressively crushed the northern hemisphere. The dinosaurs already possessed the biological tool needed to survive this. Originally evolved for display and retaining body heat in milder climates, dense coats of filamentous feathers were rapidly selected for extreme cold weather insulation. Picture giant woolly ceratopians and heavily insulated hadrosaurs migrating across the frozen steppes. They would use their massive bulk as a thermal battery, storing heat in thick layers of fat to endure months of freezing darkness. Extreme cold rewards large bodies, a principle known as Bergmann's rule. Rather than freezing to death, the harsh climate triggered an evolutionary response that forged the largest, most heavily insulated dinosaurs the planet had ever seen. The mammals from the Mesozoic did not go extinct. Denied an empty planet to claim, they simply continued diversifying within the strict physical boundaries they had always occupied. They conquered the spaces the giant reptiles couldn't reach. They thrived in the thin, high branches of the forest canopy, expanded complex subterranean tunnel networks, and ruled the night, hunting insects and seeds while the diurnal dinosaurs slept. Look at how these sperm whales plunge vertically into the dark abyss. The one major frontier mammals could claim was the extreme deep ocean. While massive marine reptiles ruled the surface, specialized mammals evolved extreme breath-holding capabilities to hunt in the cold, crushing depths where air-breathing reptiles couldn't follow. Mammals survived as highly successful masters of the margins. They formed a vast, parallel dynasty, forever locked in the shadows of the reptilian rulers. This raises a popular piece of speculative fiction. If given an extra 66 million years, would highly social, pack-hunting dinosaurs with large brains, like the Pteranodids, have eventually built civilizations? Consider animal intelligence, like this crow manipulating a stick. The peak of dinosaur cognition would likely mirror this. They would develop complex vocal communication, coordinated pack strategies, and sophisticated tool use, operating on par with the smartest birds and primates alive today. Building a civilization requires a highly specific sequence of ecological pressures. Our ancestors were primates who spent tens of millions of years developing grasping hands and 3D spatial reasoning in the trees. Then, climate change violently forced them onto the African savanna, where they had to cooperate, communicate, and plan just to survive. Human-level consciousness is an anomaly. It is not a guaranteed evolutionary finish line that every intelligent species eventually crosses, but a highly specific, improbable ecological accident. An alternate Earth ruled by dinosaurs remains intensely wild. It is a stable, thriving planet completely devoid of concrete cities, industrial pollution, and technological manipulation. A 230 million-year dynasty is not a failure simply because it never produced astronomers or philosophers. It is an ecosystem populated by organisms perfectly adapted to their environment, functioning exactly as biology intended. Our ability to even ask these questions relies entirely on a 10-kilometer rock arriving at the exact right coordinates at the exact right moment. Evolution is a beautiful, indifferent process of survival, and our presence here is just a cosmic stroke of luck.